Hey everyone, it's been a while. I'm back for a little while and I'm working on this virtual machine that I've worked on before. You may recognize it from my Decker implementation that I worked on some time ago. It's the same thing, there's multiple implementations. This one runs in the terminal. This is my instruction set. But we're going to work on a version that runs in the terminal here. And I'm working on a, that's the wrong thing. I am working on a, well, you'll see, a little terminal device. So if I go into the Pascal folder, I can run instant FPC. That's the free Pascal compiler. B to build it, and B4I is the interactive interpreter. And when I stick an X on the end, we get this fancy thing that you're about to see, which is this. So right now, we've got the interactive assembler down here. You can say things like, you know, 2, or say 2, 3, add, and you see that it puts the number 5 on the data stack. It's a stack machine, and I see my camera's running out of space. I hope I have some time here. I'll keep an eye on that. Not space, but energy. Anyway, this is the interactive interpreter for the assembly language. This is the assembly language, but you can actually run it in real time and emulate it. And you can also compile it. So you can, or not compile it, but lay it down into the memory. So if we do the same thing and we make a function called, like, 5, we could say 2, 3, add, return. And then when we call it, let's see, we zap that 5. Now it's gone. And we can call 5 again now. Ooh, and it crashes. Well, that's the terrible news. How about we do it this way? Oh, I know why, because right, because you can't just when you do that, you have to say load byte 5, load byte 2. Actually, there's a constant 2, and then you can add them together and return them. And now if you call 5, then it puts the number 7 on the stack because I said 2 and 5, not 2 and 3. Anyway, Open Studio. It says warning. The last time I got a warning, it told me that there was something wrong. It's lower than the recommended bit rate. We recommend that you use a stream rate of, okay, so last time I got about like 2 frames per second, but I can see even in the preview that, like, it's moving around in real time. So it's just a low bit rate. I'm okay with that. Sorry, let's move on. All right, I'm just going to jump right in. I'll explain things as I go. So basically, what I want to do today is I want to work on this top part. So as you kind of saw, this is like putting stuff into RAM. So this is address 256, so hex 100. And you can look at that, and you can see the same thing right here. So this is like a live view of the RAM. We're going to put another live view here, but it's going to render it as a terminal rather than as this like debug area. So we're actually going to use this implementation is in Pascal, so we're going to use the free Pascal compiler, as you've seen a little bit of. And we're going to talk to Gemini to make that work. So Gemini is this new Google thing. I guess it's been around a while, but this is a command line version, or a terminal version, and they call it a CLI, but it's not a command line. It's its own little command line. All right, but we're going to say, I'm going to bring up an editor here. I think I should start the server start. That way all the Emacs buffers share the same memory. And we're going to load, I guess we want to load this b4ix.pass. For some reason, ever since I loaded my Emacs config, font lock mode, it just doesn't fontify Pascal files anymore, unless you run the command. Anyway, so this is b4ix. This is that thing I was just looking at. This, let me switch over there. Oops. for IX. So this is this, and it's pretty straightforward. Most of this file is just like wrapping, the actual library, the interactive assembler and all that stuff is in UB4i, the unit B4i. B4 the virtual machine, I is the interactive interpreter. UB4 is the virtual machine. CRT is what does all this like fancy colored stuff, and sysutils is just sysutils. And we've got some things like drawing headings, which is these lines right here. One of them happens to be gold. Eventually, you're going to be able to tab between these things and like jump up to the terminal or interactively debug stuff. Term window, init term, main window, state window. These are just drawing these windows. Show state is drawing all this. And most of it you can see is just already coming from like show mem is already coming from the internals of the VM. This is all stuff that's available from the command line. You can say the same thing. If you say b4i.pass, you can see the same things, but there's no GUI shell here. And this is what the tests run. But I wanted something that was much nicer for me, that was interactive and kind of a little closer to the experience I get with Decker. You might notice that this machine has like very few colors. So this is actually shelling into a little laptop that I have that it was running Ubuntu, and I upgraded it, and it just couldn't run the latest graphical Ubuntu. So I installed the server version, and so it's like literally running in the console with like 16 color VGA, text terminal, no graphics at all. It actually can run Decker, but and STL programs, but there's no X and there's no window manager or anything like that. You can run one full screen graphics program at a time with STL. Anyway, that explains the colors. What else do I want to say? Anyway, so I was working, this is why I wanted it in the terminal. You actually can run Decker, but I just wanted like a nice terminal thing, and so that inspired me to work on this. And let's see what we got. So one of the first things I did recently, let's go to this other file called term.b4a. You can actually say, let's see, what directory are we in? And this is in the BIOS directory. I can say import or interpret BIOS. Actually, I don't want to interpret it. I want to assemble it. A BIOS term.b4a. Wow. A BIOS term.b4a. As you see, it's kind of crashy at the moment. I don't have all the errors trapped. So that's why I want to be able to not have to type everything in this window. I want to be able to load it from a file. So what that did is just loaded this program right here, which is a single function called fill memory. And this gives you a little bit of a flavor of what the virtual machine syntax looks like. This is let me just read it. So these are comments. This is saying, this is like the before and after. It's called a stack picture. So it takes 3 arguments on the stack. So, if we say like let's do it in hex, AA, BB, CC. See, they're on the stack here. I can swap them. And so now we have A, CC, BB. I can add them together, and we get some big number, which is also a hex number. And then we can subtract them, and we get some negative number. We can zap it. We can do all kinds of things. We can do all these things, actually. Oh, a little hard to see. So we can say b4i-o and then to quit, and it runs those commands. So these are all the commands that we can run at the moment. Most of them are dealing with these 32 registers. Like half these are bytes, so it's a byte code. And the first, I guess, 128 register or operations are like syntactic sugar or not syntactic sugar, but they're opcodes that do these things. So this one, this is like a little dictionary. So these are 1-letter functions that you can invoke. So each register has an address, or has one value in it. And basically, if you call this function, it invokes right? If you call this opcode, like this would invoke the function in register D, this invokes the function in register E, and so on. This looks at these values. So the @ sign looks inside and says what's in there, and puts that value on the stack. This takes a value off the stack and sticks it into that register. And this this is a little complicated. This takes a value off the stack, adds it to the register, and then returns what used to be in the register. So you can do that. It's kind of like a plus plus operator in C, like C plus, A plus, I plus plus, or whatever. You can like add the 1. You say constant 1, which is these are the constant functions. You say C1, and then plus A, and that returns what A used to be and adds 1 to the A register. So that's that. And then there's all these, like you got some math operators: add, sub, multiply, divide, a modulo, which is the remainder. You got shift the bits, and or XOR not. You got some comparisons: equal, less than. That's the only two you get. You can use not and swap and things like that to get the other ones. Do duplicates the thing on the stack. Swap over takes the, maybe I'll fire up an, I can do another one. So if you say, A, B, and then you look at the stack, you have A and B on the stack, and if you say over, and then you look at the stack again, you copy the A over there. That's what over does. Zap, as you saw, removes this, removes the top item on the stack. So this is growing this way. The stack is stacking up this way. There's a second stack that you can't see called the return stack. I guess you can't see either of them here. So if I press DC, that takes data to the return stack. I see D, well, there's nothing there. See, now the B, now that B moved over to this other stack. And if I say CD and then look at the two stacks again, you can see that it moved back to the data stack. That's CD and DB, and then these are all reading a value out of memory. So if I assemble something into memory and I say, like, let's do a FF, then I can say 100 load byte DS, sorry, D, and then you'll see that it. Well, first of all, we can look at address 100, and you can see that I put the FF there. That happens to be an opcode called halt, so showing you the assembly mnemonics. And if I say 100 read that byte, then I can display the stack, and we'll see AB, and it should say FF. Yeah, and if I drop it, or actually if I do 100, I can read it as a signed byte, -1, and I can do 100, and I can read it as an integer, which would put it as, I think FF000, we'll see what that says, which would be some big negative number, I think. Let's see. Oh, it's just FF, that's right, because it's little endian. Yeah. Okay, and then we can also read and write an integer. This is read an integer. You can write an integer. You can load a byte. You can load a short or a signed integer, which is what I did here to get a -1. A load actually is when you're executing. It says wherever you are in memory. So if we say 100 and we say load byte 5, return. Now when we look at 100, we see load byte, and then 5 shows up as this opcode here. But when we run it, I'm not really sure why this HL is there. That's weird. I think it didn't reset the. It didn't go backwards. Interesting. So I think we actually have to say 101. Let's see, 101, and then let's add like 101. Yeah, that's the code I want to run. So let's call that So it's load number 5. So let's put that in the 5 register, or the F register, or what's 5 in V, right? So let's put that in the V register, and then we can say, yeah. So what's our data stack? And then we say run V, and then what's our data stack now? And it should have a 5 in it. All right. So anyway, that's the gist of it. I think I covered all of them. These are constant functions: C0, C1, C2, -1, and C4. Constant 4. So these are the kind of the most important constants that you're always referring to, and it just saves you a byte when you say load byte or load signed or whatever. It's just saving you a little bit of extra time. TM is an old version of this terminal op, which I'm looking to override. And then, like, I think you say, like, you do a C and you want to like echo it, you can push that to the thing, push that to the stack. So these are ASCII characters. See them. And then we say IO, and it should print the letter C. And then having removed both of those from the stack. This is the letter E saying emit, and this is the letter C, which is the thing we wanted to emit. And then the rest of these are like internal stuff. I think they're exposing like Pascal functions to write a line. I think DS displays the stack. Yeah. So these are kind of redundant now because they're also built into the, but like before I had even this, that was a way to trigger that kind of stuff, trigger inspection and that kind of thing. All right, let's just jump in and write some code. I'm kind of curious whether Gemini can write some code. It did help me find a bug in this program yesterday, so that was helpful. But we'll see. I was gonna read what that said. Let me just go ahead and read what it said. So you've got an address you want to put things into. So set n. So you're going to use this pattern I and copy it n times as a 4-byte number, starting at this address. So we're going to stick the address into A, but first we have to look at what's in A right now, because we have to say we don't want to lose it, we don't want to corrupt it. So whatever's at A, stick it on the control stack. That's like the return stack, right? That has the address of where we're going to go when we finish this function when we call return. And so until we call return, we can use that stack for other purposes. So we push it to the control stack. Now we take this A that's the parameter and stick it, whatever's on the top of the stack, stick it into this A register that we've just saved. And now we've got a for loop. This is like a little macro. And basically what it does is that this jumps back to here. So it's a for next loop. And it's going to do it like a certain number of times. So this is going to, right, so then we're taking this n, we're going to do it that many times. So for n, so it's going to pop something off the stack, and then, this thing is going to take, at runtime, is going to push that n over onto the control stack, and then there's an opcode called next, which is right here, which I didn't mention. These are jump, hop if 0, call, return. So this is a jump to an absolute address. This jumps relative. Let's call a hop. Hop if 0, if the top of the stack is 0. This calls a function, this returns from a function, and this is this loop operator I'm talking about next. So for next, and basically what it does is it looks at the thing on the stack and it just counts down to 0. So it's doing this loop for n equals n down to 0. So that's what where the n goes, that n becomes the loop there. So that's what this .f and .m do. They're not opcodes, they generate opcodes and they call this next and jump and that kind of thing. So it saves you the bother of having to calculate addresses and stuff. It's an assembler macro. Anyway, so then, so now we're going to take that leaves us with the pattern. So we're going to copy that pattern. We're going to copy the number 4, and like I said, basically this is saying a plus equals 4. So yeah, so copy, and then but it also when we call wi, so what this does, this says when we say dupe, that makes a copy of the I, so so the stack looks like I, and then we stick a 4 on the stack, we add that to the A, and then we return what was in the A. So now we have I and an address, and then we write it. We write an integer, so the I and the address and this WI writes the integer. It consumes those top two, leaving just the copy of the pattern. And in the meantime, it stuck a copy of that in memory. And then we do that in a loop over and over and over again. And when we're done, we're left with just that one I on the stack, the one copy of the pattern. And so we're going to zap it. And then we pop the old value of the A, we put it back in the register, and then we return. That's the basic idea. And when we do that, that clears the memory. So if I do that, so we can we want to assemble that. Let's term.b4a, and then we can say, let's put the pattern do 04, 03, 02, 01. So it's big end or little endian, so it's going to be reversed in. Right, this number is reversed from the way you write the number as a single number is reversed from how it's laid out in memory. So we're going to make let's do 8 copies of it, starting at 140, which is this address right here. So these 2 lines are going to be filled as soon as we write FLN, or it's going to crash. Ah, it worked. Okay. And you can see they're the opcodes A, B, C, D, E, F, G. So that's it. That's this interactive assembler. And just to make it absolutely clear, I just called this function, this \A assembled this file into this RAM right here. Okay, so here you can see that after the bang A, the F doesn't do anything. Actually, it's just DC, sorry. So the F turns into DC. And then we have the DU, the C4, the plus A, the WI, they're verbatim. And then this .next turns into N, or .n turns into NX, and then HX. Which is actually saying some negative number. So HX is one of those little silly opcodes. Like I think it actually prints something out which you can't even see yet. Prints out the number 6. Prints out the number in hex. So it's like a high-level opcode that I stuck in there just for to help me with debugging. But what this basically means is it's like a negative number. It's like a short. So it's saying this is the value that says hop back to right here. Right here to right here. So this, whatever negative number this is, it tells you it goes back here. So it's like -1, 2, 3, 4, 5, 6, 7, whatever it is. Anyway, we have the zap, the CD, the bang A, and the return, and they're all just verbatim. So this was assembled into memory, and then these two .f and .n are macros. That's it. Okay, that's enough blathering about that. All right, what we're going to do is we're going to copy this same kind of thing. So the reason I did this was to fill the screen up. I filled it up down here. I want to fill it up with the spaces when I clear the screen. So that's why it's part of terminal. And we're going to have another one when we want to scroll the screen up, which is to copy memory. Not just to fill memory, but to copy one register to another. So we'll have 2 of these little pointers, and we'll do a loop, and we'll cause the screen to scroll up. So hopefully we'll get to that in a little bit, if I don't just keep rambling and talking. So let's just jump in and do it. I see my battery's at 17%. How can I make that not be? Let me just double check to see if I can get that to plug in somehow. How it was plugged in. Plug in. Well, this might be short. Do I have a battery that works? I bought batteries. I have a brand new battery right here. But is it charged? That's the question. Okay. Well, let's see. That was 24 minutes. So I have about 8 minutes left. I'm surprised it's not charging while it's plugged in. That's interesting. 1 second. I'm going to lose the picture here, I think. Question is, will it come back? Oh, it came back. All right, look at that. And here we are. Okay. Better? Cool. So that was the break. I only rambled for 25 minutes this time before I started working. Hopefully I started working. Let's see. Okay, let's jump in. That was enough of a crash course. Let's jump in. So the first thing I want to do is I'm going to pick an area in memory. And we're going to say term window. Let's say draw term. Unit term. Draw term, and we're going to give this a Gemini in a minute. Begin, end. All right, and let's call it down here, init term. And right after everything we do, we're going to draw the prompt, show the state, and how about we draw term? Draw term. Is it draw term or show term? Draw term. So that would be term window, and then we're going to loop through through 64 by 16 bytes, starting at, and we're going to just make a constant for now. Let's call it const screen. And that is going to be, it is an address. It's a UB4 address. Wow. I forget how to set this. The Pascal mode is weird. Emacs. It's like ancient. It's like hasn't been worked on in like 100 years. And it's just going to be C00. Starting at screen and draw those characters. All right. And we'll do text adder equals 0.7 for now, which is just white on, or black on white, or sorry, white on black. Okay, so I've added a stub of for a draw term procedure to B4IX. Can you fill it in for me, please? And I'm gonna just actually, it usually doesn't like screw things up too bad, but first of all, let's make sure that ran. So run it again. Oh, it didn't. $38, what did I do wrong? Oh, yeah, I put that in there. That's the normal assignment operator, but this is an equality. All right, so that ran. It just, it didn't do anything. Just to show you what it's doing, hello. If I write hello there, it'll appear at the top. Yeah, pointing. Does that work? Pointing. Interesting. All right, because I have to press enter, right, and then it shows up there. Hey, that's not right. Oh, I see. This. Probably we're going to have one of these, this old X and old Y for both of them. But what I'm going to do is I'm just, instead of show state, I'm going to, you see what happened? It put the prompt up here. So what I'm going to do is I'm just going to move this draw term before that. So I just swapped those two words. All right, so press enter, it shows a hello up there. Oh, but it didn't do the... yeah, we have to say store XY. We have to, all right, so we're going to say, we're going to extract these. Here, old X, old Y, keyword. I really don't like the and we'll say fetch XY. Store and restore, or load XY maybe. Load XY, and we'll just reverse these. But I think it's actually go to XY. Go to XY, old X, old Y. You can see it put this in this. Put this relative to the end of that word. So that's not what I wanted. I wanted it to be. I want this to fill up, and I want it to remember the position of the last cursor here. This is where your cursor was. Probably eventually each one of these windows will have its own old X and old Y and just remember state. But for that, so yeah, so let's move those out, and we'll put it down here. All right, so we'll say main window, XY. Now it doesn't matter what order we do them in. To begin, we'll say store XY, draw the term. Show say these are all function or procedure calls. You don't have to pass the parentheses in if there's no arguments, and then draw the prompt, which is a little bit like Forth, but before being a Forth-like language. This is Pascal. I think I've said that 3 times. Okay, so that didn't work. What did I do wrong? Oh, we didn't initialize. So we will set those to. We'll just set them at the start. Old X. When we say we have an init term, but we don't have init for the other two. Old X equals 1. Old Y equals 1. All right, run it one more. See, now this prompt is down here. That's not what we want. All right, wait. That didn't work. Oh, I see. There's some duplication here. So at the very start, we've gone to the bottom of the window of this main window. Okay, text color dark gray is making this prompt right here. We're gonna write that. Okay. So now, if not done, you can be done if you immediately if you pass a parameter up here. Oh, right. Then repeat until done or EO are in the file right. All right. Okay. So here we go. I think that's it. Not because I put the Q on front. Now if we say, so the hello is up there right away, that's what I kind of expected. Say to add. This is what this should have been a repeat loop to begin with, and I don't know why it did this. There's something wrong here. To add. Like, why doesn't that prompt get shown? Repeat. Read the line. Write a line. And then by the time we wrap around here, it should have drawn the prompt again. I don't know why. That seems like a problem in like the CRT unit or something. Like I don't get it. All right, so I'm gonna just make this a function call. Oops. Function redraw. And so prompt is not being used here. Like I don't know why you should have to call it this way. Repeat redraw. All right. Let's see if this works. There's no return, so it's a procedure. Procedure. Why doesn't it draw the prompt again? It says right there, draw the prompt. Read the line. Maybe this is doing something? No. They're flush? Oh, what do I do? Huh! You can't kill it now. Because I... that's not going to kill it, is it? No, so before IX. Yeah, and it's now stopped. But it didn't interpret it, so I stopped the interpreter. So it didn't, I couldn't quit. Yeah, I have no idea. Let's try this. Flush. I have no clue why that doesn't work. There's some kind of buffering issue happening. I don't get it. Difficult function called a sine CRT here? No. No, I don't remember how it works. I'm not going to guess at it. All right, so let's fix this. Whatever this is, this should draw the thing, but we're just going to... I'm going to put that back. Not then. If not then begin. Redraw, repeat. End. And then redraw again. Let's do it like EOF or no, I think you have to do this. If not done, or EOF. Yeah, that's fine. I don't even think we have an EOF condition anymore. Because what does it mean? Eventually, this is gonna be, the terminal is gonna be in direct mode anyway. All right. So anyway, so that's what I wanted. It's scrolling within that window. Everything's good. All right. So let's git add b4ix.pass. All right, so I've added a stub called draw term. I'm going to ask Gemini to fill it in. So it knows about the whole project here, right? Because I gave it a file called Gemini, or I asked it to generate a file called Gemini.md that has like its a summary of everything that it's learned about the system right now. So it's taking notes here, and so every time it logs in, you can see it says using 2 Gemini.md files. So there's this one, and somehow it's saving some yeah, you can tell it. Oh, there's no way to type in it right now. But when it's not working, you can type memory, and you can add a memory, and you can have it remember things, which I guess is the second file somewhere. I don't know why it's called MD, because it's not called MD. Okay, so this is a new service, and like people are using it like crazy, so it's a little bit slow. You saw it took all that time just to get just to respond. All right, so here it came up with that window. It knows what memory is. So memory is just like a global that's coming out of the UB4. Right now, there's only one instance of the virtual machine. So eventually, when I do this again, I'm going to have to like encapsulate that in an object so that I can have multiple versions or multiple instances of the VM running simultaneously, and they can talk to each other. Although I may also do that by shelling out to the program, and that way you can run the other implementations in the shell. But we'll see. Anyway, but so it's a global called mem, which is it's not a global. It's in the namespace of the unit called UB4, which is the virtual machine. And then presumably, if I press Control S to show more lines here, I can see the and then yeah, I can page up inside of this program as TMUX. It's terminal multiplexer. That's how I'm having Emacs and the Gemini thing running side by side. Yeah, see, I wanted to see where it defined these words. So it deleted my stuff, or it reformatted my stuff. Instead of writing hello and my comment, it's looping through. All right, so we're going to allow it to do that. And it's going to make that change. And so as soon as it's done here, so I can say revert buffer. All right, we can see that it's got the code here. And well, you didn't actually make it. it ran make C pass, but it didn't actually work. That's okay, because we're going to test right here. Okay, so if that worked, we should be able to put a piece of, like a value into the thing. So let's put the letter C at C. That's where the terminal is. So let's put the letter, let's put an exclamation point there. C00. And then we're going to write a byte, and it should show up right there. Do I have it backwards? No, you always put the address second. If I say exclamation point C or 100, right byte, it should show up right here. Yes? Yeah, that's what I expected. Okay, so why is it showing up there? Where did I put the code? Right, draw term, okay. No. Yeah, for y equals 0 to 15, go to xy 1, y plus 1. Term window, text it. You go here, write that character. Term window is this window. All right, just I'm gonna say I'm gonna make it blue. Should be 6, 4. I don't know, it might not come out blue. Red, whatever. Oh, and I don't have a. Alright, so C, what was it? C00, right byte. Y0, y times 64 plus x. I'm gonna set the starting buffer to 140 just so I can see it. And we're gonna put this at 140. And it didn't do anything. And I'm just going to put a vertical bar here. Right, but it has to be assignment operator. Right, that's what I expected to see. Like the code that it generated looks right to me. What am I doing wrong? We're looping. You loop from the y's. Go to xy, 1 is the correct, and then y plus 1. It's called hexit. I did that again, didn't I? Illegal character. What? Oh, okay. First of all, so term window. know what's happening here. I see what's happening. It's the same thing that's happening down here, is that it's scrolling. Gets to the bottom and it scrolls. I know there's a way to make it not scroll. But maybe it wasn't through this. Okay, so what I'm going to do is I'm going to make this window 65. I'm just going to make it one character larger. All right, I'm going to make the right. I'll make the terminal 17. Ah, that's annoying. All right, I will fix that later. Because that has something to do with it. It has something to do with hitting that last character. But it also doesn't matter because I can, I'll draw these headers again. So in redraw, I'll draw the headers again. And I have to say full screen. Full screen, draw headings. Then do this. full screen does not exist. One screen max X and screen max Y. Ooh. Oh, because I didn't call it. I copied it, but I didn't. Full screen. Okay. So where did I do it? Red. I was at 4.7, right? They have names, but I just, there's only 16 colors, so not that hard. And we're not going to make it 65. We're going to make it 64. Okay, so that's 16 lines. And we will get rid of those numbers. So hex it. We'll just comment that out for now. In case I need it later, I will come back and get it back. Okay, so now, if the screen address is 140, so we can say 140 write byte. That's what I expected the first time. I don't know why. I don't see that what I did fix that. What did I do that would fix that? To go to XY, y plus 1 was there to begin with. Somehow that was putting it down here, though. It could be there's some buffering issues with the right, because like the same thing with the prompt. Like my logic tells me that I know what I'm doing. Sometimes I get confused, but when I know it's right, and so there's some kind of buffering issue here that's causing it to like not emit at exactly the right time. I don't know. I don't know. There could be a bug in the CRT, or like I could be doing something screwy. Like I don't know. It could be that something. I wonder. No. There's a unit called video that, or maybe KVM. Yeah, I had previously been using this other library besides the CRT library that comes with Pascal. This is a nice library, and it like came from the DOS days, and like you have direct access to the video RAM on a VGA monitor, or an Intel machine with a VGA port in there, and whatever. So I've been using this for many years, so like I know how this works, and this is not working the way it's supposed to work. There's like some issue is happening here, but it's working now. So whatever I've done has seemed to have appeased it. So there you go. Okay, so anyway, so now we can poke things into memory directly, which is what you could also do in the DOS days. So we can say H. I know it. How about we'll say we can just assemble something to that place. So 140, we can say H. We have to quote each character L O comma space. I don't know if I can write a space like that, so we'll try it. So 20 is character 32, which is space. Hello, WORLD. So this is invoking the assembler. It's going to invoke that right there at the start of video memory, and it should say hello world at the top. It did not. This is not working. This is meant to work. All right, so let's fix that. First of all, well, we'll fix it in a minute. How can I make that happen? I'm just gonna see, like it's supposed to. There we go. Okay. So that is supposed to compile to a particular place in memory, and it's not. So we'll fix that. But first, before ix.pass, we'll add that, and we will say git cache. What do? We added a virtual so before ix, what do? We add memory mapped screen buffer. Okay. Now let's complain to Gemini. So I'm gonna say here's that memory thing. And add something. Ooh, all kinds of stuff like that. All right, so let's see. There seems to be a problem in UB4I where no matter what address I use for the hex notation, it always assembles starting at the here pointer. I type 200, it should start assembling at address 200 or 200, which is 512. 200 and continue, and then next time I start and the here pointer should then point to the last assembled address after that. Okay, so I'm going to let it do that, and then I'm going to write a test for it. So in the b4i.pass, whoops, b4i tests, I'm finding all kinds of bugs in here. Okay, so first, the very first thing, interactive assembler, assemble to address, into any address. So let's call it name b4i adders. So adder, and then this is b4a. This is not actually b4a. This is like the test language, which is the same, except the input lines have this little sign in front of it, greater than sign, and then the output has this, and then this is like really should be outside of this block, but it's like the description of the test. Okay, First 40 lines. Okay, so we'll see what it did in a minute. But basically, if I say 100, AABB, and then I ask for what's at 100. We'll do C1, C0, C1. Oh, we'll do like A and B like that. And then if I ask, so that's input. The output is on the next line. And then I ask for what's at 100, and it should show me 100. No, it should show me 0, 100, 0, 1, 0, 0. It should say A, B, and then that's 8, and this 3 times. Okay, that should be 16. Okay, so then if I go to 102, and I split C and B, or C and D, and then I do this. Oops. And I put CV, then I should see and I deleted one too many. Okay. And then if I go back to 100 and I put X and Y, I should be able to write over that memory. Oh, actually, this is not a good test. Let's skip this. Let's skip some. So 104. And then we should say, right? That's what we should see. And then if we do this, wait, I did that wrong. We want to see these, and then we remove these. And then I do this, and then we should see X and Y. And then further, if I ask for what's at 104, I should not see this, and not see this, and not see this. And I should only see these. And then the rest of them should be filled in with zeros. And this should say 104. And that's the test. And if I run that test, let's see, where can I go? Yeah, test before I pass. Yeah, so all this is failing. So that one is failing. And let's see if this fixes it. So let's see what it had to say. All that was from pressing Control S to show more. Or maybe I didn't. I pressed the wrong button. Yeah, I pressed Control S to show. Okay, and then in tmux, I'm going to scroll up a little bit just so I can see what it asked me to do. So what does it do? In putmem, which is the thing that writes to memory, and these are all lines are all wrapping and stuff. So it does check if it's a reg character. Okay. Ooh, what is all this? Find the first space. Man, I really don't like that, but that's kind of ugly. Start at the first space. I'm not really impressed with this code. So if there's an address, So when you start it, strings are one indexed in this, or at least this kind of string is one indexed, starting with 1. So 2 is the second character. So stripping off that. So this handles the case of colon, colon. Which is what I want. And this string is later. We can just return early if the length of the string is 1. We can cut out these. Well, I'll clean this up in a minute. Right now, I'm just checking to see if I even want to accept this into it. Like this is a lot messier than it usually does. It's not very pretty. But I think generally this is okay. So if there's an address string, then assemble the code string. Okay. We'll allow it. We'll clean it up a little bit. See, now it has to stick it into. Why does it take so long to do that? Why is it still turning now? I don't know. So what file was that? You are not done. You didn't make the file correctly. To make before I run cd pass and then make I don't know if I trust that. Let's call this test. Oh, it didn't put. It doesn't use these numbers. It looks like it's mostly working except for these numbers. Let's remove. And run the test again. What's wrong? This looks very close. Is the test wrong? Yes, the test is wrong because I didn't ask for this. And then this should pass. And this is a failing test that was already failed. So this is fine. All right, so let's go ahead and Emacs UB for I.pass. Oops. B4. Emacs pass UB for I.pass. Revert buffer, yes. And I just want to clean that up a little bit. Actually, let's put on this. And we were looking at put in. All right, so if length string equals 1, then exit, which is how you say return in Pascal. And that allows us to not do this. Let me put that in quotes so it's clear that that's what the syntax is. Okay, so really what we want is this token right here. So self does nothing. Find space. I already have this header string. So if p equals 0, then no space. So we're just defining a label. So we're going to copy the string from position 2 to the end of the word, to length string, which is this, which is what ASM string was. Is that right? Else e minus 1. Label plus code. Okay, so we have the address now. They really made a mess of this. This logic is not clear. Okay, so okay. How about we do something like this? Begin, and we'll put a code string is just equal to the empty string. So the code string is going to be actually I really want to say switch case p of 0 Why is this not indented? I'm missing a okay. And then else begin. I'm going to ask it to double check my logic here. It usually does not make code this convoluted. But it did this time, so. Oh, we know there's a code, so it's p to the length of the string. Okay. So then that's the end of the case statement. Nope. That's the end of the else statement, and then the end statement, case statement. That's the end case. All right, so otherwise it's a name. If address string is there even any meaning to that? Like I think if I run this and I say A, B, C, oh, sorry, A, B, it starts the assembler and it should assemble right here. That's what I would expect. So there, I don't know why I invented this syntax. It makes no sense. It doesn't do anything special that this doesn't do. Oh, hello. I see people are watching. Welcome. I can make this a little bigger and see. Oh. Hello. Yeah, I think this syntax is redundant because you just like they both mean turn on the assembler. And but for the sake of whatever other tests I have, I'll leave that there. You know, I'll just I think I'm going to get rid of this colon. There's no, if it's, why did it change? What? No? Who changed it? Oh, maybe I when I ran this, it might have touched it. But really, yes, edit it. Yes. Now, if it's start the assembler. If it's so really, if it is reg character, if it's length 1 and is reg character addr string 1 R, and set register R to here. And really, see, it's like a little state machine. It should. Is that why I need that? Is that why I need the double colon? I don't think so. I'm at 1% again on these batteries. I don't know if I have another battery. I don't know why it's not charging. Maybe this is a good place to stop. I think, well, I guess I can just turn off my low pace camera. Yeah, well, I guess when the camera dies, I'll turn that off. I'll charge these batteries to figure out why it's not charging. If it's any hex address set here to that address, and really you ought to be able to you know what, I'm just gonna roll this whole thing back. Do I want this? Do I want to keep this at all? It's more like this. Toke. Why does it line that up like that? Toke is a string. For toke in split string. Yeah. For toke in really, you should even be able to do this in like the middle of a line. Yeah, like in the little version of this, mv4.deck. there's like a little state machine. And it's like really complicated because you go through each one and like each thing can say, well, like this is not the best code probably. This kind of grew out of hand as well. But you can see there's all these like states. So if you're assembling, you can either be in the comment state, assembling, or interpreting. How's it go like this? State to make an enum, state assemb, state comment, state interp, state run. Well, okay, but you can have multiple colons on one line. If the line starts with the, okay, so if help 1 equals then handle address. Else begin assemble token. Begin if then toke 1 continue if then toke equals 2 then continue then and is reg except we want toke now. And my least favorite thing about Pascal, you have to the binding on the and operator is, or the precedence on the and operator is ridiculous. Then begin end. So this would be handle. So basically, register equals or do set register R to here. Here is the address where we're assembling the here pointer, which I think is just a register called HP or something like that. Or it might actually be in slot 0. I don't remember. Where did I put it? Okay, so how would we just say toke equals do toke equals toke cut. I think that's copy. copy toke to length toke. Part of this is I'm just not fluent in this anymore. I used to like know this stuff inside out, and I had all these helper routines. It was much more pleasant. This is very unpleasant to me right now. All right, so then strip off the and continue. Toke equals 1. There we go. Toke 1. Then begin. So stupid. Why is that length? Is that because I'm missing a? Yeah, it's because that. Again, it was telling me the right thing. I was just being mad. All right, so if I can make this in here, and of course it doesn't want to indent that, so. Else we can even put a continue in here. I don't like that. Else if try hex toke A to begin. Problem is that like if you give it a name like babe or something, then that's going to be a hex, and you want it to be hex is only allowed to be uppercase. So I think is uppercase. 3 Pascal is uppercase. Is upper is what I was looking for. Hey, like the whole string, right? String, okay. It is upper toke and try hex toke A to begin. Handle the set here pointer to the address, and else it's not do begin, it's then begin. Why? Come on. This is how you indent code. Else define a name, new entry. All right, and that's it. else, these comments are the same. This is a line comment. This is a nested comment or whatever. Okay, so then I think you can also say, yeah. Okay. This is how you set that register. Nope, this is how you set the here pointer. This is going to fail with the type error. Define a new entry. I think this is the same thing too. That's it. I think that's it. And then end the for loop. Oh, there's one more end going. All right, what did I miss? So this is to begin and end of the full function as a whole. This is begin and end of the for loop. This is begin and end of this. It had to be a block because of that. All right, that's it. So here we want to say register R, right? I don't think this is right. I'm gonna let Gemini fix this. Maybe this is right. We'll find out in a minute if it compiles. I don't think this is right. And I could look at it, but like this is the kind of thing that an LLM is pretty good at doing. So do I have ASM string anymore? No, I just have token, right? I have token. We have adder. And we don't need P anymore. So just token and A, those are the only things. And then R. And R is a so what UB4ASM.pass is reg chair. Takes a byte. Oh, that was already there. R byte. Okay, so oops. And I think we're good. I like that. All right, I'm going to add that to get add UB4I.pass. Yeah, so we're going to add that, and then I rewrote your logic. Let's just see it, run it and see if it passes. Yeah, I didn't even think. Length. I'm not super lazy, right? UB4A.pass. No, what was it? UB4I.pass. Len. Gutha. Illegal assignment to for loop variable toke. Okay. G string array, huh? I'm gonna let it fix it. I really thought you could do it that way. All right. And then line 56. Local variable A does not seem to be initialized. I'm gonna ask this thing to fix it. And I see my battery died. So I'll turn that little thing off. Can you help me fix it? Oh, split strings calls out a delimiter. Okay, so sure, fix it. What? Identifier not found, try hex. That's not the issue. See, sometimes it doesn't really get Pascal sometimes. Basically, this needs to be up here. And that's the problem. No, it just needs... I really thought all this stuff was done, you know. Compiling is successful. Okay. And then let's see if it runs the test. Yes, it did. Okay. Ah, that was right. I don't like doing that too. I integrate 0. Okay, so UV for I, fix footprint. Okay, so that was a complete detour. I added a test. Why isn't what did I do? I screwed something up. Okay. In D293A244. Oh, way back here. What is happening? Look at that. This is not in the... Okay, what have I done wrong? Interactive assembler is not in here. I ran git stash at some point, didn't I? Yes, really edit the buffer. Yes, save. That's why. Okay. Now I'm ahead by one commit, so I can add this commit. Okay. Git add b4i test.org. Git commit amend. To allow address. Okay, and then git stash pop, and it should not have a conflict. I did git restore git diff pass b4i.pass. I don't think I was doing anything. Right, it was just this nonsense, and that's why I stashed it. Git restore. How do you do it? Git restore stage pass b4i pass. Okay. And then just restore it completely. Okay. Okay, so now we're back to where I expected to be at the start of this video. So we had a little detour where this little assembler thing didn't work, but now it is working again. So, all right. So now that might explain why this wasn't putting the code in the right place. Anyway, so we're reading this thing. If everything is still going well, we should be able to assemble directly to that spot, which I believe is 140. And so now we should be able to say, hello, oops, H, I'll write it, and then we have to, oh, we can't do it that way. This is not a real line editor yet. HELL.O. And there we go. We assembled it directly into memory, and this is reading that chunk of memory to generate the screen. Okay. So now, BIOS term.v4a. Yes, read that. Okay, so we have fill memory. All right, so what I want to do is I want to see if Gemini can derive clear screen from this. So, what it should do is, so we can assemble that, BIOS term.v4a. Oh, so now, yeah, the assembler, but that's actually the code of that, so we don't want that. So we want to go back to 100, and I can't press up yet, so a BIOS term.v4a. So we put it back here, and then hopefully, if I say FLM, it's at 100 and not wherever this was. not at 14C. Yeah, okay. So now we can say we want to fill the screen with spaces basically. So that would be 20, 20, 20, 20, or not 20, it's always 20, 20, 20. This is, that's 4 spaces in a like a string crammed into one integer. And then we have 64 times 16. So we can just multiply that together. We can, I think it's 1024. But we don't have to figure that out ourselves because we have a fourth. And then starting at the screen address, which is 140. And then we will run fill memory. And that should fill that with, boom, okay. Okay, so let's split that here and make that into a little test case. So in the past, we'll say test dot c screen clear screen dot b4i interpreter. And what we want to do is we want to assemble that. So bios.b4a. And then we're going to do what I just said. So that was we're going to call this. Before that, we're going to do 20, 20, 20, 20. And then we're going to do, oh, I know what I did. I did 64. Right. This is 64. I typed 64. So I went past memory, didn't I? Access violation. Yeah, I went past the end of RAM. I overwrote the stack. I did all that stuff. All right, so yeah, so this is all hex. So it's 20. And then 20 would be 64. And 16 would be, is that right? 20. 20 is 32. So 40 would be 62. And then 10 would be, really 400 is just, 400 is just the number that we would multiply to get. So this is what we're doing. So I type reset there. And then we can press up a couple times. And then I expect this to work now. But I'll say interpret C screen w'. Okay. What does FLM mean? Oh, okay. All right, because it's not, it's term.b4a. Let's try that again. Ooh. Am I crazy? Oh, right, we don't, I did it again. I overwrote memory again. It's not 64 times 16. It's 64 times 4. So 64 would be this, and then, so that's 100. Let me see if I got it. 60, so we say hex of 16 times 64 should be 400, and then, right, because this function uses 4 at a time. It's using read integer and write integer, so it's reading 4 at a time. Okay. And now it worked, and you can see it filled it with your with the space. Is that right? We say at 120 and we put a space. If we put at 120, we put a 20. Yeah, okay. So this is not a good character. This is not a good character to use. In fact, okay. Okay, so that's kind of cool. That's a clear screen right there. Whereas previously it was a null character, and it was just writing the null character over and over again. But if we write this as, so if we go up here, we can reset the whole machine. And if we set this to like, we put a 61 in here, or 61, that will be the letter A. So load C screen, or not load, it's interpret C screen at B4I. There's \A to assemble something and \I to interpret the assembly. Boom, there you go. So we could make some little pattern here, like, oh, I don't know, figure out what to go. So if we want to put like a dot, that's 2E. So you see I pushed it onto the data stack. So we put 2E in here somewhere. And that'll put an A dot. And if we put this, that's 28. And if we put that, that's 29. So if we load it again, there you go. So maybe we just put 28, 29. That's a 5C. And the 28 again. There you go. Some little background. That's a screensaver for you. Okay. So it only does this at the end of a statement here. So it only updates the screen when I press enter. So I can't do like an animation or anything up here yet. Okay. So now, anyway, so we want to clear the screen. So how about we call this or whatever. I'm just curious whether or not like really we could. I mean, I could just. I'll see if it does the next one. All right, so we want to say I think this is legal by the rules I just gave, but how do we make a constant? Any underscore? I'm just making this up. I'm making up a rule. So we're going to say the screen is going to be 140, which is 40.01.00.00 in there. So we're going to load the screen dynamically. Screen. I'll just call it screen. I'm not going to do these capital letters. There we go. We could put a star or something in front of it. Something like that. To indicate that it's a. All right, so let's load that again. Invalid op RB. Right, because you got to return. Invalid op RB. This could be screwing something up. Invalid op RV. All right, load int. I don't know why That was saying RV, but okay. Ah, I see. That's what the problem is. Oh. So it's the assembler is having problem with something here. Invalid op RV. So the assembler is dying on something. What is it dying on? Can we not assemble that yet? Can we not put screen 1, 2, 3? Okay. And then test at screen. Okay, that's another bug. That should assemble. That should have worked. Okay, but I'm pretty sure that's in the assembler. BIOS that I've been using forever. Did I just break that just now? e4a.org. I'm looking for an instance where I've used a word and written to that word. Maybe I don't have any variables in this. Yeah. I don't have any variables here. Huh. So the problem is I don't have tests for these. Yeah, like a lot of this stuff works in this version of the system. Like I made it in here, and I use like at cells and at start and so on. So I defined a variable, and then now I add something to it and so on. So all this runs in the little version. I've gotten used to this, but like I did all this interactive stuff, and I haven't brought the other implementations up to speed with it. I thought I was there, but I didn't write test cases for all that stuff either. I just kind of made it up as I went along, and I was experimenting, and I didn't back it up with tests. Most of the other stuff is like the actual ops are backed up with tests, but the interpreter is not. And so yeah, so that made problems for me. So I keep running into things where I think that things are working, but then I just haven't implemented them in this version of the interpreter yet, and I don't have tests to tell me that should be a thing you can do. But I believe I can say this. So let's try this. So I don't want to retype all that every time. So let's try this. 1, 2, 3, 4, and then we can say test. If we can't say at screen, And we say $ screen, we should put the number in there, and we should say CL $screen, not $, load integer $screen. We're going to load that. Yeah, we're just going to load the address. That's all I wanted to do. That's all this was, or I could say read integer. And this should have been a macro for that. So let's see if it works. Unknown word $. What about backtick? Possibly the thing I just made. Does not, still not do it. So put mem could still be wrong. But like it knows, right? Like if I write what is screen, it should know this. Invalid address screen. All right, so it did not add this. So let's write, we'll say labels. Interactive labels. So that is a B4I label. So this works in the assembler, but it's not working interactively. So we got to say def. We'll just call it def 1, 2, 3, and then we'll say 1, 2, 3, 4, and then we will say $def, and that should tell us 100. Right, that's what I would expect it to say. Here, reset. Here. So if we say, what did I just say? Def 1, 2, 3, 4. Shift enter. And then if I say $def, is it backtick def? Yeah, and it put 100 on the stack, or 100 on the stack. Is it ? Also does that. Which I think is redundant. All right, so if I say this, and then $ds, that should say ds. Well, you should say just like this. Oh, sorry, ds 100. ds space 100. No, ds : space 100. Okay. Okay, so that's what I would expect to work. I believe that test will fail. But I need D4I test passing. What? Oh, inside the assembler doesn't know how to do it. So that test works, but if we then say what do we do? So inside the assembler, can we say ds? No, not ds, but can we say backtick ds? Yes. Oh, come on, not ds, sorry. I should have said def. This is in the way. This is something I was working on. So I need to go back up to 100. Let's go to 0, 2, 0. 100, that's fine. 0, 0. All right, so that's the 1. The A is the 1 in 1, 0, 0, 0. Or 0, 0, 0, 0, 0, 0, 0, 1, which is this one. Ah, right, so 0, 0, 1, 0, no, 0, 0, 0, 1, 0, 0, 0, 0 is 0, 0, 0, 1, and then a 0, 0, and a 0, 0 off to the left, backwards. Right, so this is the address, so that worked. This should have worked. Let me just do that again. 100, and we'll do X, Y, Z, A. X, Y, Z, A. Interesting that it doesn't show. Oh, and then we want that again, and then we'll say def, which is 100. We'll say A, B, C, D. Try that again. That's not what I was thinking. Okay. Start over. Def 1, A, B, C, D. There we go. And then if we just start the assembler, say backtick def, li backtick def, return. That's what I would expect to see. All right, so we're going to put that in the test. Let's make this A, B, C, D. It should be exactly the same, except show up as plus A or something like that. And then li def return. And then if we ask for 100, 100, we should get this. Yeah, this is what I expect. We should expect to see that. And I think this test will fail. No way. This is not running. Why? Because I didn't give it a name. E4A. That is my problem. All right, now let's try it. Now this should fail. And it should also fail because unknown word def. Okay. So git add E4I test. And let's ask Gemini to do this. There is another failing test if you run E4I test E4I pass. And while it's doing that, maybe I will figure out if I can find a charger for this battery. There's one right in front of me. And I will charge my phone or my camera battery. Oh, look, I can charge two at once. You can't see that, but if I had a camera, you could see it. Oh, it's even USB. This is a nice charger. In fact, it's only USB. Okay. Charging away. And let me grab the other battery. I hope you can hear me. Everyone does not seem to do anything. Charger 1 is having no activity. Charger 2 is having field day. Alright, let's try this battery. There we go, we got two batteries charging. And the old Sony battery. Okay. Alrighty, well, I guess I do have a. There we go. Thought I had that. Huh. So much for a green screen. Let me see. Hang on. Filters, chroma key. Oh, I see. Wait, hang on. That again. Filters. Okay, it had to be on. Wait. That's not where the old cam itself is. Nope, this way. Okay. Oh, sir. All right, well, whatever. That way is not being covered. Whatever, man. I don't get it. Okay. Okay. Old cam 2, that's better. And we could have just done that with the screencast tiny. Whatever. That was a waste of time. Okay. All right, let's see what the actual problem was. That was the old error. The B4I label test is failing because the assembler is not correctly handling the def label definition. It seems that the putmem procedure is not correctly identifying a label, as instead trying to treat it as a command. I will now modify putmem. Okay, so what does it do? It should be ask the assembler with the preceding colon. Yes, yes, that's right. That didn't change anything. It didn't change anything. All right, whatever. Sometimes it does this. It can't see that it's. All right, first of all, comment. It's starting the assembler at in the wrong place. You know what? I wrote that code and then it took it away, didn't it? Like it ignored my change. I didn't read it carefully enough. Yeah, this is what I did in the real code. This is true. That is the right way to do it. See it? Oh my god. Is that really how? Come on. See, I think this is. No, that's not what I want. No, just do the on every token in the loop inside footman. I bet I can do it faster than this. I like my style better, and I put it back the way it thought it ought to be. Let's see what it comes up with. I think I don't know if I cleared it. If I cleared the memory before. I probably didn't, did I? So it still thinks it's. Yeah, I didn't clear it. I didn't clear the memory, so it's working off its memory of what the code it wrote. I'll put this up a little bit. Nope. No, there we go. Hmm. My screen is so tiny I can barely see this. How long have I been doing this? 3 hours now? Yeah, it's supposed to be half an hour working on the terminal. It's 3 hours working on the assembler. Yeah, I'm gonna wrap this up. All right, so let's just accept this and see what it says, and we'll clean it up by hand. Yeah, see, it's doing 2 loops, and whereas I had written it to 1 loop, and I asked it to fix the errors, and it didn't. Okay, so let's just stop this. We're gonna clear this before we ask it to do anything again, because it's gonna screw up the. I did something. I don't think that works, does it? Or maybe it just can't. Okay. All right, so first it's failing on this, which is wrong. Okay. What? I'm gonna. And then it fails on unknown word depth. All right, but I can reverse the order of these two things so I can put this test first, which is what I care about. All right. Yes, this is what I want. If I don't know why I need W toke. W toke equals toke. Say toke. If the length of the token is 0, then continue. If token 1 equals 1, or equals a colon, then begin. That's the word. If length, then continue. Right? That's right. Right, that's correct. But this is just toke. I expect this to work. And else, and then we don't need anything. Yeah, this is exactly the code that was there before. Yeah. Not exactly. The loop is slightly different, but. And then line 71, I messed up. Because I had an extra. We don't need that. We don't need that. Okay, good, good, good. So the address failed. Why? So the parser for the address is failing now. This says to patch your output, you need to remove this. Remove this line and add this line. So AB is not being printed. I'm not seeing the bug right away. It's failing on this issue right here. This one is failing right now. What changed? Instead of trihex token A, then this, we're saying if trihex W token A, whereas W token is the copy. I'm gonna print this out. It's the first test, so yeah, that's right. I'm not seeing how I broke it. Now, this is old. Right? Unless you can't do this, but it's letting me do it, so. No errors, no messages at all. But it didn't assemble it. It didn't assemble these characters. All right, so there's an if that says something's wrong with that if statement. Where'd the code go? I gotta get that fixed. I don't know. Something's wrong with my Emacs config. This machine. All right, let's assume that's okay. That worked. This should be token too. Because wtoke was not the right thing. Okay, so that was the problem. That was the bug. All right, so we can quit that. There we go. Now we're back to the real bug, which was unknown word death. Actually, let's do this. And the words that are defined. So there are no words defined after ABC 1, 2, 3. There are no words defined. That's causing another, oh my goodness. It shouldn't ever see that word. This new thing doesn't have, okay, so. There is a bug that it does, that the interactive assembler doesn't understand the comments, but And now if I P, I can, if I hit \P, I can see that there's a film defined. And now I think this might work. No, it doesn't know. So it doesn't see it in the could it be that every time I'm starting the assembler, is wiping out the memory and it's not persisting over time? That's probably what it is. B for A, because previously the assembler only worked like every time I start the assembler, I think it's wiping it out. I think this right here is correct. So let's add this. We're not going to check it in yet, but I think there's a second bug. Whatever. I guess I should save that. So see what the difference was. But it wasn't looking at code that I would do. Okay. I think it's not really a bug. It's a bug in the sense that I'm expecting the code to do something that it's not doing. That, ooh, what is this? Somehow I got into an editor for this prompt, maybe? I think what's happening is in the assembler, it's yeah, that's what's happening. Every time we start the assembler, well, we do want to clear the forwards. But we don't want to clear the dictionary. We only want to do that at the start. There's probably like there probably ought to be an interactive assembler command that clears the dictionary, and there is in here. This little C clears the dictionary, the assembler's dictionary. But I think this solves the problem now. Does not. Say H123 Z A, B, C. Now we print the words that we know. No, it doesn't know any words. What's happening? What is causing it to clear the dictionary then? Ah, I see. Nth equals 0. So that's also the counter for the number of entries is also that cleared. That was what I was afraid of. So 1, 2, 3. Oh, I didn't recompile. Fast. Make run I think is what it's called. So now if I say ABC 1 XDEF or 2, and then I print that. That's good. 2. But if I say ABC 1, 2, 3, right? That doesn't treat it as a word. So I need to test whether the entire string is uppercase. Or I make try hex do that. So you see, the problem is that ABC is a hex number, but it should only do that if it's uppercase. I thought that was B format. Okay, first of all, we fixed something. UB4 ASM, make persist dictionary between runs. persist dictionary return. That's the bug fix. Okay, and then now cd cached uv4i.pass. This does work. The only problem is that try hex is not working. So this fixes the, I believe this fixes the problem that we were having. So let's just double check test v4i.pass. Oh. How can that be? Def a b c d def who def. It's a hex word. It's a def is a hex word. Okay, so I got to fix the hex word problem. But so let's call it def n in the test. So we'll call it name, call it label, LAB, LBL. This should work. LBL. And that also would explain LBL. Okay, that would also explain why. I'm not sure why it pushed the number 10 onto the stack. All right. So test edge case hex labels names that are also hex. So we'll call hex name. Right, because you only want to do uppercase hex. Only uppercase hex should work. So label still failed, but it didn't fail because it doesn't know what label is. It failed because label is being pushed on. Number 30 is being pushed on to the stack. 30 is being pushed onto the stack. That's probably a bug in UV4i. Like the compiled version worked. No? Yes. But I have to show it like that. I actually don't mind that. I think that's actually the right behavior. That's 1, 2, 3, 4. and 0100. So show the full big address there. That's okay, I like that. But this fails. I don't know why that fails. And that is probably because in here, if length of token equals 1, then invalid control character. Oh, this is some old thing. This is redundant. This is what it's doing is it's putting the whatever's in L, the L register. Would I ever need this for anything? Like this is saying like whatever is this is like a macro that is saying put whatever is in the assembler at the moment. Assemble it. So you could do like conditional compilation. Like dynamic compilation, like templates. Or like I'm not opposed to that, but what this really should do here is I'm going to put that in the plan to think about. And just maybe later. Idea. In assembler to compile to run in B4A, B4I to run a dynamic macro template compilation coding. I'm not sure. I don't know. In while assembling. I don't know. I don't know if that's for. But what this should really do is so we should call this like chomp or something. Take that first character off. So begin that if and D put adder, that's it. Else error unknown word. Unknown word. Is this coming from here? No. So which line is that coming from? So much for my 4 hours into this again. But the word is because the problem is because it's hex. Okay, so the test passed. The label test passed. We tried our pass. UB for I. Fixes for non-text named labels. Okay, and now try hex. Where's try hex? We're going to reuse that. For I equals C chair for C in toke do if not is upper C, then exit false. Is upper is in unit character. If not, so it can be a digit or it can be an uppercase letter. Otherwise, exit. This test is failing. Okay, so that fixed the test. That fixed all this stuff. And it fixed the hex issue. So def is now not giving an error about can't find def. It knows what def is. It knows where it is. It's correct about that. GA pass, UB4I pass. But the test is still failing because the test is wrong. It's missing the, like I had to fix it up here first. Missing this call to see what that is. And then it's also missing this. And then this is the previous test that failed. This is what should clear the dictionary, I think. Does not clear memory, no, so that just resets the stack. Okay. I might change that. All right, so git add b4i test.org. Git add pass ub4i pass gd cache. Those are the tests, and then we add this character. Okay. So git status and git push m or git commit. And what do? We are saying ub4i ignore or treat lower case hex as names. Only allow uppercase hex for addresses. Treat lowercase hex as a name. Okay. But that is not the problem for this. Is it? No. Now this might the issues with that with what am I trying to run? This one BIOS term.b4a. This might have been caused by the assembler flipping out every time, but maybe not. I'm not sure. Let's run this again. That seems to have worked. We have a screen defined, but we don't have film. Wait, what has happened here? Film M, we don't have film M. Okay, so I want A files B term invalid op RV. That worked. It's the @ sign that is causing a problem here. Oh, our RV is a read value. It's now called read integer. So where is RV coming from? grep RNI RV UB4 pass UB4 ASM. No. Just startup pass. Right here in UB4 ASM. UB4 ASM dot. How on earth has that not failed in like oh, because I didn't have any variables in the BIOS. I checked that. That's it. All right. I really need a test to expose that. I'm not going to write it to do. I'm going to write the test. It's actually in the main B4 test. Like, where do you put that? It's almost like It kind of, no, it's this. Okay, so if we say oh, I know why. It's because I only, like, the variables I use are bytes. So we're going to say int 01, 02, 03, 04. We'll say 4, 3, 2, 1. In the assembler, we say set, and that is int, and or get and set. Get int return, set return. So what are we gonna do? I guess then we say interactively we say int and get and ds. And that should say ds 01, 02, 03, 04, which would just be this twice. Well, that's no good. Can I run? I don't know if I can run it. But I don't want to fix that right now. Hang on, is this real? Yes, there's a real problem with the first test. So many bugs. The same thing, this is the same issue. It was previously saying that RV failed, now it's saying WV failed. And again, it's just right integer. Why do I keep thinking this is? But it does not put two of them up there. Because the assembler doesn't know what they, I mean the B4I doesn't know what they are. So get only puts one of them there. But this was previously failing. And then, so we should have B4I get set. And then B4A. And then at the B4I level. And so then we should be able to get this, and then we should say like 5 set, and then get, and then we just put that all in one line. And now it should say a 5 after this. It has 2 5s. And we forgot to quit. So this needs to quit. And same thing here, we want to do the same thing. But really we don't need this. This is the test already for the assembler, and then now we just want to say at int, and that should say that number, and then we should say 5 and save it into int. I'm going to zap that, put 5 into int, and then do int again, and do the stack. Or let's say do the stack here. Stack should be empty. And then at int and do the stack and then quit. And the stack should be 5. These tests are running through to each other, I think, because this is not indented. That is indented. Now I'll try it again. Yes, okay. So I'm not sure this should work in the plain assembler. The idea is that you should be able to implement like the basic assembler very, very quickly, and you shouldn't have to deal with all this mess. And so the basic assembler is very, very compact and small. And this is the extended assembler. So this actually goes in the B4I tests. All right. So this is a regression that we have. All right, but I'm going to say git add. All right, first of all, gd pass ub4 asm dot pass. So git add b4 test.org and ub4 asm dot pass. Okay. ub4 asm. Allow I'm going to put these in single quotes, so the exclamation point, name and in B4A. And then add failing test for who in B4I. Okay. Okay, so now can we implement clear screen? Okay, I think so. I think that was it. All these bugs. Okay, so if I run, I get. Okay, that didn't work. What is happening? Okay, so 2020 at screen. It doesn't know what at screen means, which is the failing test that I just had. Okay. Okay, but we just know it. We know what screen is. Screen is 120. 2020 140. No, that's the starting address. We want, oh yeah, so that's actually wrong. This code's wrong. So the first argument is the pattern, which is I. Second pattern is the number of objects that we want to do. So that is 100. But I don't think I can write that. So li 1 that'd be 00010000. And then we put the address to start at, which is the screen, build memory, and return. Okay. I run this one more time. I run C screen. This is wrong. There is an opcode named, what if I say admo? That's wrong. Okay. This is a bug. 1, 2, adbo. See, it added them together. Just look at the first two characters. I had all this stuff worked out in the little version, you know? I'm gonna... in B format. Okay, so the problem is that this name not be that because it starts with, that's actually call. How can it, clear screen. Loaded that, only loaded one number. Read integer, and then call. I'm reading this code. So it loads this onto the stack. That's right here. And then it should load this value onto the stack. And then again. And then read an integer. And then it's going to call film mem, and it's going to return. Well, why didn't it? Well, I only wanted to fill it with like 8, I think. This was the wrong value. I wanted to put like 8 on here. So n is 8. So I is this number. And then C8 is not a real number. That's not a C4. And then, so I'm going to make 4 copies of it. Or I could say LB load by 8. By 08. Okay. QRS. But it doesn't do it. It doesn't load the second number. Let me remove the call to fill mem. I just want to see how this sets up. Okay, I have an extra 0 here. Load integer. That works. And then load byte 08. Breaking it into 2. Is that what's happening? No, that can't be what's happening. There's no way that's what's happening. Oh, 08. Why? You don't know what screen means. Again, that's a failing test. So, 100. Oh, that's not what we wanted though. We wanted 2020. 2020, 2020. 20202020. We want the 8. And then we want the screen, which is 100. I want to read that integer, which should be the 140. This should be exactly the same. Something is wrong here. It's adding an extra 0 there. Except I didn't say RI. That comes from doing screen and then fill mem, and so that should make 2 rows of these @ signs. And just so all that's working, but these tests are failing Oops. And this is failing. And this should not fail. But I don't think I have added this to. I don't think I've added this syntax that says here's the input. It doesn't know how to do this. And doesn't know how to do this. And then in the regular test, the assembler test, why is this failing? I broke this. This is a regression. I should be able to fix this. I think I'm just going to fix this and then I'm going to call it a night because it's going on forever. I can't leave a regression. Like these should always pass. Like all of the implementations run this, but I'm adding this interactive stuff, and that's what's breaking things. But so this should never. We should never let these tests fail. Yeah. So that would be in UB for A.pass. No, in for I.pass. And I should look for that backtick word. Oh. If we want a handy way to refer to the address, we use backtick X. Yeah. Okay, okay. So I have to do that if I remove this feature. This was a working thing. I completely hallucinated what it does. All this does is it writes the code for the address. If so, is reg chair is reg chair. Yeah. If is register character toke 1, if length toke, well, we'll just do it here. If length toke equals 2 and is reg character toke 1, this is what was there previously. I don't have to reassign this. This can be inlined. And because it's inlined, that means, oops, else so if the length of the token equals 2 and token 2 R, then dput reg address of R. Ooh. Expected care. Author divide test pass. Okay. So GD pass UB4I dot pass. I don't know why you need to quote these things. Is this really a useful tool? Currently, it compiles the address of the register. But why do you need that? All right. So GG pass UB4I dot pass. Restore to assemble register of address. Why? What happened? It doesn't like this. It doesn't like that backtick. Bash didn't like that backtick. Okay. Well, that's not really what I said I would. Let me try one more time. No, I can't. I can't do it. I can't clear the screen because all this stuff is broken. And I don't know why this is broken, because this really shouldn't be broken. I don't know why that extra zero is getting in there. Zero 8. Where is the 0 coming from? But it's not caused by this. All right, so this, I need to fix this. Like, bug. And we don't know why. All right, so actually, I did draw the video buffer. That works. And I started on clear screen. I couldn't get through clearing screen because of all these bugs. What are you gonna do? All right. Well, yeah, it's 4 hours and 20 minutes in, and almost 11:30. So I'm going to go to bed. Thanks for anybody who tuned in. I will try and do this again, and actually, implement what I said I was going to implement. I'm thinking of doing it like a series of these things. Like once I get it going, this is like content for a course. Like, I want to show you how to bootstrap this, but you got to rehearse it. This is rehearsing, and it's painful. Anyway, that's why this is the unedited funky channel. But whatever. Thanks for anybody who did tune in, and I will see you guys again hopefully a little sooner, and hopefully this video actually worked this time. All right, see you guys. Bye.